We're solving the related rates problem, ripples in a pond. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. So that means it's kind of like a target, right? You've got one point in the center, and then a circle, and then a circle, and then a circle, just getting bigger and bigger. The radius r of the outer ripple, so the circle that is furthest to the outside, is increasing, right? You've got a circle, and it's getting bigger and bigger. So the radius is increasing. That radius is increasing at a rate of 1 foot per second. So that is a rate with regards to the radius. Now we are told that at the instant where the radius is 4 feet, we want to know the rate that the area A of the disturbed water is changing. So we need the area. The shape is a circle. So our function is, or our formula is A equals pi r squared. Our two variables are A and R. So A equals something, dA dt equals something, dt. R equals something, and dr dt equals something. Okay. Pretty much only the variables where there's an exponent you're going to need a number for, and you also need numbers for your rates. We are told that R is increasing at a rate of 1 foot per second. Increasing means that rate of R is positive, so positive 1 foot per second. At this instant in time, the radius is 4 feet. We want to know what is the rate of A. So this is the thing we don't know, but it is in feet something. Let's see, area is feet squared. Time is measured in seconds. The area of the circle is increasing, so we know that our answer should be a positive value. We could figure out A by plugging in 4 here, but we probably don't need to. Let's take the derivative of this and see what we get. The derivative of A with respect to t is dA dt. On the right side, pi is a number. It's 3.14-ish. So we are not doing the product rule. We're just doing a power rule. 2 gets brought down in front, 2 pi times r, right? That's r to the first power now because you decrease the 2 by 1. You just took a derivative of r with respect to t, so you multiply times dr dt. Now over here, I put d with a capital R. That should absolutely be a lowercase r. There could be potentially problems in the future where some variables are uppercase and some are lowercase. So let's just be consistent with how we write it. dr dt. Okay. At this point, we plug in all of the things that we possibly can. dA dt we don't know, so we'll leave it. dA dt equals 2 pi times r at this instant is 4 feet. dr dt is a constant. It is 1. We're told that it's constant somewhere here. And great, we only have one variable left. It is dA dt. And that equals, multiply this all together, 2 times 4 times 1 is 8, so 8 pi. And we are not told that we have to have decimals or anything like that, so we'll just leave it as 8 pi. We already know that we're supposed to have feet squared per second as our label. We were figuring out that A had to be a positive rate because our circle is increasing in area. And hey, look, it is positive. Perfect. All right, let's make our sentence. We start our sentences with at the instant. At. Trying to combine two words together. At the instant. When r equals 4 feet. Because r is changing. It's only 4 feet for a split second. The area of the disturbed water You have to figure out if it is increasing or decreasing. Since that rate is positive, you put is increasing at a rate of. Then no matter if this was positive or negative, you use the positive version, which it's like the absolute value of that is 8 pi square feet per second. Done.